Hey, today we are talking about what is rheoscopic fluid, and it's really cool. It's about as close as science gets to a magic potion. Okay, first off, what is rheoscopic fluid? Well, rheoscopic fluid is essentially water mixed with some sort of shiny, insoluble flakes or powder. So in my case, I'm using mica as the shiny thing that doesn't dissolve in the water, but you could maybe use aluminum oxide or a few other things like that, but mica is the most common and the safest. So if you wanted to make this yourself, just take a tiny little teaspoon of mica, which is something they use in makeup, and mix it in with water, and then boom, you've made your own rheoscopic fluid. Alright, so that's how you make rheoscopic fluid, but what is it and what is it used for? Because this is a fascinating piece of educational material. Alright, so rheoscopic fluid is used mainly to show currents and to show flow. So if I were to spin this up with that, depending on the speed and direction of the current, it changes the way that the light reflects off of the internal mica, the things that are reflecting light, and creates this swirling, shimmering pattern. It's very, very fascinating and looks absolutely stunning. So I'm going to try a few different experiments here with rheoscopic fluid. First off, I'm going to show a little bit of convection, so I'll maybe put this into a smaller beaker, and I'll turn on the hot plate so we can see some of the hot liquid rising to the surface and then sinking down, and constantly we'll see some heat eddies forming. Pour in the rheoscopic fluid. There's a few bubbles, but that's okay. That looks amazing. Now I'm going to turn on the heat, and then we'll zoom in so we can see some of these very cool convection currents. As the liquid warms up down below, you can see it rising to the surface of the beaker. And the stuff at the top, which is cooler than the bottom, sinks down, which then gets warmed up, and the cycle repeats itself. That is so cool! And really, this is the only way that you can actually see convection currents like this. So cool. So why does this exist? Well, this was actually used to create more aerodynamic vehicles and shapes back when we didn't have such accurate or advanced computer models to be able to see where the slipstreams were, where the drag was being created. So how about, let's see here. I'll turn off the heat because I think that served its purpose, and I'll get rid of this once it's cooled down. I'm going to change the camera to above. I'm going to put it inside of a petri dish, and then I'll drag certain things through it so you can see exactly where the currents are existing. If there's no movement in the liquid, it just looks kind of vaguely, kind of oily. But if I were to drag this through, we see where the currents are. So if I stir it like this, you can see exactly where the fluid is moving. And then it settles back down. You know what? I'm going to switch to a bigger container here. I'm going to create a current in a circular fashion, so we just have a consistent current. There we go. And you can see it. Now, if I were to place this like so, you can see visually exactly where the eddy currents are that's slowing things down. And that is very useful from an engineering design point of view. Such a cool fluid. Now, if you want some more information on rheoscopic fluid, rheoscopic and most things to do with science have either Greek or Latin root words. And rheoscopic is from the Greek rheo, which means current or flow, and scopic, which means instrument to see. So rheoscopic, really, its literal translation is an instrument to see current or flow, or current look. So rheoscopic fluid, the current look fluid, or the look at the flow fluid. It's very cool. Now, I want to try and make this one step farther. We have rheoscopic fluid, and this is one that I bought from an educational supply store. And at the same time, I managed to pick up some glow bright concentrate, which makes liquids glow a bright green under ultraviolet light. So I want to try and mix rheoscopic fluid with UV sensitive material, so hopefully we get a cool kind of ultraviolet glowing rheoscopic effect. All right, now we're in the darkened studio. I have a black light here, an ultraviolet light, and you can see that if I shine it on the rheoscopic fluid, there's really no effect. And in the dark, you can't really see how cool those shiny, glimmery currents are. This is glow bright. It's an unremarkable liquid until you shine black light on it, then it becomes very remarkable. It glows a bright fluorescent green. So let's mix up these two things together and we'll see what happens. Now, let's see. Okay, that's cool. Let's mix this all together. Oh, that is awesome. We have successfully created ultraviolet sensitive rheoscopic fluid. Let's turn this pitch black and see how this looks. That is really cool. Well, there you go. What is rheoscopic fluid? It's water mixed with a little bit of mica, sometimes even fish scales actually. We covered the origin of the word and what it was used for. This is Destructive Creativity and I'm Jonathan Allers. Make sure you hit that like and subscribe button because it really helps us out. We have new stuff coming out every single Wednesday morning. See you next time. Bye.